So example number 1, determine the x and y components of the following. So let's start with letter A. So what we're going to do here is, of course, we're get the components. Remember, components, whenever there is an inclined force, AT, so it should have a component. So I'll represent here. This would be, so let me change this line. So this would be the component along x, so I'll call this as fx, and the direction is to the right because AT is inclined to the right, and Fy would be upward. So there. So we're using 70, and 70 is measured from the vertical. Therefore, let's transform the figure. If this is our AT here in this direction, and then we have vertical for Fy. So vertical for Fy, and then for the horizontal, Fx. So also do not forget that the angle is measured from the vertical, and that angle is 70 degrees. Okay, so now forming a right triangle, Fx here is equal to the F sine of 70, where F is equal to 80, and that's sine 70. So it's sine because this F here, or this line here, is opposite to that angle. So suka tuwa, remember from trigonometry. So suwa, no, suka tuwa. So sine opposite, cosine adjacent. Then tangent is opposite over adjacent. So here. So we have Fx, and Fx is equal to, I have a calculator here, 80 sine of 70. So the answer is 75.175. And the unit here is in kilonewtons. So this would be in kilonewtons. This is your final answer for your Fx. How about for your Fy? Fy would be a function equal to F cosine of 70 because Fy is adjacent. So that's cosine. So here, F is 80 and you have cosine of 70. So Fy is equal to 80 cosine of 70, and that's 27.362. So that's 27.362 kilonewtons, and this is your angle, or the force, is inclined down. So therefore, the forces would be to the right, and this is Fx, and this is downward, Fy. So if we're going to isolate the figure, it's basically this one as the 50, and you have this one as your fx, and this one as your fy. But what is the inclination? So we will be using this triangle here. So if that is the triangle, ato siyang i-isolate. This one. Atong i-isolate ang triangle. It's a triangle 3 by 5. So triangle nga 3 by 5. Okay, so this is 3 and this is 5. So we have two similar triangles, one here, then the other one is here. So this is in the same orientation with 3, together with fy in the same direction with 5. Then for 50, dapat na siya pair. So I'll just call here as a function z para mo na yung pair. So if that's the case, we can now get the value of our z. How do we get the value of our z? By Pythagorean theorem, that z is equal to the square root of the 3 squared plus the 5 squared, because that's a perfect right triangle. So z is equal to the square root of 3 square plus 5 square, and that is square root of 34. That is the value of our z. So we can now have the ratio and proportion for us to be able to solve for fx and fy. So by ratio and proportion, actually there are two ways to solving this problem. It's either using the triangle or using the inclination of the 50. So since we're using the ratio and proportion, so I'll just transfer this. Okay. I'll just transfer it here. And this one, I'll just delete that. Okay. And I'll just change the font size. So this is 3 and this is 5. Okay, so let us now solve for fx and fy. So by ratio and proportion, we will have fx in relation to its 50. And that's equal to, since we're using the horizontal here, then we will be using that horizontal there. That's 3, and then since we're using 50, then we have to pair it with z. So what is our z? Z is square root of 34. So now fx is equal to 3 times 50 over square root of 34. So fx is equal to, so let's have 3 times 50 divided by square root of 34. The answer is 25.725. And the unit is in kilonewtons. This is your final answer. How about for fy? So it's the same, fy over 50. So we're using fy and 50. And that is to be equated with, since fy is vertical, we'll use 5. So that's equal to 5. And since nag-use man ta sa 50, we will use the z. And z is square root of 34. So now fy is equal to 5 times 50 over the square root of 34. So fy, sa atong execute, you have 5 times 50 square root of 34. That's 42.875 kilonewtons. So that's one way of solving that problem. Let's have the second way, or the other way. So remember that we're using this triangle. So instead of using that that triangle as a basis for lengths, might as well transform it into angles. So here, let's just copy this one because it's really important to know that. So this is another way of solving. Okay, so our objective is to solve for the inclination either here. I'll call this as theta, or I'll call this as omega. In my case, I'd like to use this theta. Okay, so if theta is measured from the horizontal here towards its inclination, somehow in this triangle we can create a theta from the horizontal to the inclination. And theta, that's also theta. Remember, we're using the ratio and proportion from the previous solution because we're relating similar triangles. So if we're talking about similar triangles, then somehow they're having the same or similar angle of inclination. If that's the case, then we could solve for the theta using the 3 and 5. So that function is a tangent function. So the tangent function of that angle theta is equal to the opposite angle 5 over 3. So the tangent theta, or the theta rather, the theta is equal to, let's get its function, 5 over 3. Now this is arc tangent of 5 over 3. So that's arc tangent of 5 over 3. So theta is now 59.036. So if that's the case, we may now proceed in solving for fx. Since fx is adjacent to this angle, so therefore fx is the 50 cosine of the angle nga 59.036. So fx is equal to, so 50 cosine of 59.036. And the answer is 25.725. 25.725 kilonewtons. And this answer here must also be the same answer from the previous solution. So let's check if they're the same. So yes, they're actually the same with different approaches. So if that's the case, then let's continue solving for fy. Fy is opposite to that angle. So if that's opposite, then that would be 50 sine of the angle nga theta. That's 59.036. And we're expecting a value to be 42.875. So fy is equal to 50 sine of 59.036. So that's 42.875. 0.875 kilo newtons. And somehow it coincided with this. So that's example number 1. Let's proceed to our example number 2.